back everyone to another video of the Laplace series. Today we're going to be talking about how to solve ODEs that involve the unit step function. The unit step function, as we have covered in a previous video, is just a function that basically switches values after a certain value for t or x or whatever it will be your independent variable. At least for the unit step function, we have that the value is 0 before a, and then after it passes a, it switches to 1. You can see basically this is how it looks like. The graph ut minus a is after a value of a, it's that. And we also have talked about if you multiply a function times the unit step function, before a, the value is 0, and after a, basically that function starts per se. So for this one, the Laplace of the unit step function, it's u of t minus a, and this equals to e to the negative as over s. This is a Laplace transform if you're taking it of just the unit step function with nothing else multiplied and said. If you multiply something times the unit step function, for example, a function t minus a, then this is where we get t-shift, which we have covered in another video that you can watch here in the description, shown over here. But we have already talked about this, but this is going to play a lot into equations like this, involved with the unit step function, and then later on with the Dirac delta function, there will be a lot of t-shifting and these kinds of ODEs. So as long as you see an exponential in the s, you're most unlikely going to do a t-shift. So let's see an example. So we have y double prime minus 6y prime plus 8y equals to u of t minus 3, where both initial conditions are equal to 0. So as always, I like to take the Laplace of every single term and then put it back together. So for y double prime, we get s squared capital Y minus sy of 0 minus y prime of 0, which in this case, because both y of 0 and y prime of 0 are zeros, basically they can be canceled out and we're only left with s squared capital Y. For the Laplace of 6y prime, you can see that we can factor out the 6 and basically multiply times the whole derivative of y prime, or another derivative times the whole Laplace of y prime. And the Laplace of y prime, it's s capital Y minus y of 0. But once again, because y of 0, it's 0, we can remove it and we're only left with 6s capital Y. We then have that Laplace of 8y is just 8y. And taking the Laplace of the unit step function in this case will be e to the negative 3s over s, as you can see in the formulas on the right. So now we put everything together. We have s squared capital Y minus 6s capital Y plus 8 capital Y equals to e to the negative 3s over s. We factor out a capital Y. We're only left with this quadratic equation, and then we solve for capital Y by dividing by that, and we're going to get the following. Now I don't that one in the bottom, that quadratic equation can be factored out, and we can get our answer to be e to the negative 3s over s times s minus 2 times s minus 4. And that is not a final solution. That is just halfway through. That is the Laplace solution, but not the y of t that we're looking for. So to solve it back to the t domain, we need to take basically the Laplace inverse. So taking the Laplace inverse of capital Y will give us y of t. So that means I need to take the Laplace inverse of e to the negative 3s over s times s minus 2 times s minus 4. And as you notice, that exponential there, an exponential in the s domain, will correspond to a t-shift whenever you're doing the Laplace inverse. So that means that I can get rid of that, and it will come to play in a little bit. So by doing partial fraction decomposition, I can solve for the whole terms here. So instead of having 1 of s times s minus 2 times s minus 4, I can break it off into 3 fractions that equals a over s plus b over s minus 2 plus c over s minus 4. And you can see the numerators are always a power less than the denominators. That's what the top are constants, the bottoms are equations to the power of 1. So if we were to take the Laplace of these terms just as they are right now, just like in a general solution, you can see that that t-shift will come play now here in green. Basically, we'll be multiplying a whole Laplace inverse times u of t minus 3. And every t that will appear, we are going to be shifting it for t minus 3. So basically, the Laplace of those terms, we're going to get a plus be to the 2t plus ce to the 4t times ut minus 3, where t shifted from t minus 3. So it would look something like this. You can see everything in green is everything that was shifted. And now all we need to do is find the constants a, b, and c by continuing solving for the PFD. So to solve for a, b, and c, all we do is we cross multiply. So we're going to multiply a times s minus 2 and a minus 4, b times s minus 4, and c times s minus 2. Doing that, that will have all the same denominator in the bottom. So I'm skipping a step here already. If you don't know where this comes from, you can find the video regarding PFDs here in the description. As you can see that I already skipped one steps. I'm already equaling the numerators, and that's why they are equal to 1. So continue simplifying. I will basically, distribute or multiply the s times the s minus 4, s minus 2, and everything that we have there. And then afterwards, I will distribute the a, b, and c. And from this equation, I have three unknowns and only one equation. So what I'll do is I like to do the coefficients equal the coefficients on the other side. If you know any other methods, that's fine. They're as long as they're mathematically correct, you can do them. At least for me, this is what I like to do. So all the terms that have an s square, in this case, are a, b, and c, and they're equal to 0 because there's no s squares on the other side. All the terms that have an s will be negative 6a minus 4b minus 2c equals to 0. And then my constants are only have 8a equals to 1 on the other side. So solving for a, I get 1/8. If I plug it back in and solve for everything else, I get b to be negative 1/4, and I'll get c to be also 1/8. So with these values right here, if I put them back on a, b, and c, they are already found before, I can substitute it, and I'll get my final answer to be y of t is equals to 1/8 minus 1/4 e to the 2t minus 6. You can see here the 2t was distributed times the whole t minus 3 plus 1/8 e to the 4t minus 12. Once again, that 4 was distributed times t minus 3. And everything is multiplied times the unit step function, which is ut minus 3. So this is how you solve a problem regarding the unit step function. I hope this was helpful. And all the problems like this are pretty straightforward. They're really similar. And if you have any more questions, you can find other videos regarding this topic that I already posted. Until next time, good luck.